Hello, everyone. Today is February 21st, 2024. This is the Kubernetes Data Protection Working Group meeting. So today, Tom from Dell will be presenting volume replication, and then we can get the status about the CBT after that. So Tom, you want to get started? Actually, I'll stop sharing. I will make you the co-host so you can share.
Yeah, I'll need to share a screen, obviously.
Yeah. So now your co-host, you should be able to share.
Screen 3.
Can you send me this afterwards since this is updated, right? Then I can.
Absolutely. Yeah, I've added a slide or maybe two since the draft I sent you.
Okay.
Hello, everyone. You can call me Tom. I'm Thomas Watson at Dell.com, and I'm going to talk about some of the various forums and issues that we have going on with replication in Dell. So a quick outline of my talk, I'll talk about the various kinds of replication that we support pretty quickly, just to give you an idea of the variety that we're facing and some of the differences, metro, sync, async, and complex. I'll talk about an issue we have of physical versus virtual volumes. Oh, and I see that the screen didn't update. Why did that not happen?
It's updated on your side?
Yeah, it's updated on my side, but it didn't update with what I'm sharing.
Do you have two screens or just one?
I have 3 screens.
Oh, okay. Maybe it goes to some other screen or something. I don't know.
Let me try. Which screen are you seeing?
I just see the title,
The title.
your name.
Okay.
Yeah.
All right. Maybe if I hit from beginning again. Nope. I tell you what I'll do. I'll just move this over to that screen and we'll dispense with
Yeah. So now
trying
I can see all the
to
slides.
troubleshoot it.
Yeah.
Yeah. All right. So I'll talk about the various forms of replication. I'll talk about physical versus virtual PVs, meaning what do the PVs look like in a replicated situation. And I'll talk about our implementation, some thoughts on provisioning attributes, PV status, and a fair amount of detail about our implementation, all from publicly available information on our website. So to start with, we do support metro replication, and I've got 3 different slides on types of replication. And at the top of these, there's this video link up here at the top right under the title that you can go if you want to see a video demo of this replication. Metro replication is a synchronous replication that allows concurrent access from both sides. It's often used with 2 Kubernetes clusters or in a stretch cluster. Writes, of course, aren't acknowledged until it's written in both sides of the arrays. And it's active, and in this case, we map paths from both of the arrays to the host or hosts that are using the volume, and we use the multipath daemon to switch paths if one of the paths becomes unavailable. We also have sort of a...
Can I ask a question before you
Sure.
want? So this way you don't forget. So the parameters here, that's the storage class parameters, right?
Well, that's not all of them, but that's kind of the major ones.
Okay. And also, another question I have is, so you showed PV here. Does each of this cluster has its own PVC?
Yes, if there are two clusters, they each have their own PVC and PV.
Okay.
Or-
And okay, so who is replicating the application side? I mean, the storage that we know, right? There was the replication, but what about Kubernetes API objects? Who is replicating those?
I'll get to that in the implementation section.
Okay, sure.
It'll be a lot clearer, and that's down towards the end.
Okay, sounds good.
All right. Yep. All right. So next up, we have synchronous replication, which is very much like active-active, but it's not active-active. One side's active, and the other side is the IOs aren't acknowledged until they go to both arrays, but access is only enabled from one side or the other. Again, there's a demo video for this. Depending upon how synchronous replication is implemented, you may or may not have to restart the application on failure. Some other storage providers other than Dell have synchronous replication, and they don't require you to restart the application if one of the replicas fails. In our synchronous replication, though, if the active side of the replication fails, we do currently have to restart the application. We also support asynchronous replication, and it's very much like synchronous replication, except that obviously it's asynchronous, so the application needs to restart if the primary fails always. And we expose failover operations, typically called failover, failback, reprotect, test failover, fairly straightforward names for various operations that you can do on the link. So if the primary volume failed and you wanted to restart the application on the same cluster, typically the application would fail because the volume went away. You would do a failover operation, which would cause the other array to become active, and then you would need to restart the application using the PVC and PV from the other side, from the other replica. So those are the ones that we support. Our arrays also support complex topologies like the one shown here. We don't currently support these in CSI. They're simply a little too esoteric to provision through Kubernetes, and we haven't had that much demand for them, but conceivably we could do those. So, as I mentioned up front, one of the issues we have when we started replication a couple of years ago, uh, our drivers were simple and stateless, and we wanted to continue that. So, what we ended up doing is we exposed each of what I call the legs, the replica copies, as a PV. So, for synchronous or asynchronous replication, you would have one PVC PV combination representing, say, the active side, and another one representing the backup. Um, this works okay, pretty well if you want to. I mean, you have to copy the PVC PV to remote clusters. So if you have a primary copy of your application on cluster A, and a secondary copy of your application on cluster B. You can put them in the same namespace. The PVCs and PVs, we annotate them with all kinds of information about how they match up. So we know which replica, what the associated pairing is. So for one volume, we know the corresponding backup volume, for example, from annotations. So if you have say, the active PVC PV on cluster A and the backup PVC PV on cluster B, then you can fail over real easily from cluster A to cluster B with the application in the same namespace. And typically you restart the application the way that you started it originally. You can use Helm charts or operators or whatever, and they'll see the existing PVC PV and just start right up. Where we get into difficulty is if there's a stretch cluster and the user wants to restart the application on the same in the same namespace. So he's got one copy of his Postgres database or whatever in a given namespace, and he's running on what's currently the active, and the active fails, and now we want to restart. Typically, we don't don't want to rebuild the PVC in that case, because usually it's deployed as part of the Helm chart. And so what we're looking is to match, is to make an associated PV that goes with that PVC. But it's not really a supported operation to change the binding of a PVC to a different PV. There's kludgy ways to do this. You can force delete the PV and it will go into a gone state. And then if you carefully recraft a replacement PV, it will reattach to the existing PVC. We haven't used that method, but an interesting problem for us is what to do in this case. And what we originally told customers is put the active and backup copies of the application in separate namespaces, and they really don't like that solution very well. So we're looking for a solution for that. This leads you to, would it be a better idea to have a single PV that represented both copies of the volume, the active and the backup, in the case of a simple two-way replication set? For a reasonable number of replicas, like 2 or 3, we could implement this. It'd be a very large change for us to implement this, but we could implement this. And the way that that would work would be that when you started the application and you went to publish the volume, it would look to see which copy was the active, and if it needed to do a failover, and then it could automatically failover and use the other copy because the PV actually represented both copies. So we haven't done that to date. We're thinking about solutions where we might do that, but we haven't done that to date. So right now we have one PVC or one PV that represents the active and another PV that represents the backup. Was there a question there?
Yeah, sorry, I need to understand. Earlier in the slides, you had depicted a version where like it's a separate Kubernetes cluster on the other side.
Mm-hmm.
Like that's supported, right? So obviously, if it's two separate Kubernetes clusters, you definitely need two PVCs, right?
Yeah.
Like if the PVC in question is like an RWO type volume, so it's like block with the file system on it, and one of the clusters is using it, what stops the other cluster from trying to also use it at the same time and causing data corruption, which is what would happen, right?
Right. So our drivers won't allow you to map the same PVs to multiple clients at the same time for RWOs for situations. They have a check in them.
But if it's a separate Kubernetes cluster, so like only one pod is trying to consume the PVC in one cluster, and another pod is trying to consume the PVC in a different cluster, like, and underneath it's that metro replication you'd mentioned where it's bidirectional. Like I don't understand.
Metro replication allows read-write many, essentially. It is active. Both sides can map it at the same time.
But if someone creates like a block volume and then puts ext4 file system on it, and now they try to like mount that on both sides, you're
It
gonna have
works.
two writers. You're gonna have two writers writing to an ext4 file system, and it'll cause corruption.
It works. The arrays handle that situation. They have a special file system. Essentially, it's sort of a distributed file system.
Oh, okay. So you're saying you don't like you just don't have the ext4 on block file system as a use case. So you have your own file system.
Essentially, yeah. Mhm.
Is
Okay,
it a
okay.
read many for the metro case? I thought somewhere it says it's a read many. It's not.
We don't use
Yeah.
read-write many, but you can
Okay.
map both sides of the volume to different clusters.
Okay.
The arrays,
I'm wondering like
have special handling to do that.
if there was a case where like you really did need exclusive access on one of the clusters, because the workload, maybe it's a raw block workload and it presumes RWO semantics that it wants,
Right.
exclusive access.
In
And
that case, the metro probably wouldn't be applicable.
okay, so you're saying you just tell people don't do that because we don't have a way to stop bad things from happening if you do that.
Right.
And
We
you
don't
rely on. Okay.
we don't have any mechanism to prevent two clusters from trying to do that.
Okay.
So
And the file system case is handled by a file system that actually supports RWX so that it's fine for it to be shared across clusters.
yeah,
Okay.
that's only for the metro solution.
Right. What is the name of that file system? Is it something I've heard of, or is it?
It actually looks like ext4. So I don't even understand all the intricacies of it myself, to be honest. I'd have to get you an array expert probably to describe it in a whole lot more detail.
No, that's fine. I've heard of a handful of file systems that have this property, and I wondered if it was one of them that I had heard of, but it's fine. Good, go on.
I don't know is the answer for me anyway. All right, so we do have this interesting problem, and we're thinking about various ways to fix it. So we also, I thought probably one of the things that we would want to discuss is, so what if we wanted to standardize CSI? There's certain things that are common across most implementations, and that kind of universal attributes and universal statuses. I think it's really useful to know the replication mode, sync, async, because that defines to some degree the application behavior and the restart semantics. And so I think if we wanted to standardize that, that should be a first class attribute somewhere in the storage class, rather than today, all these attributes end up being in the parameters. The number of replicas is in almost every replication solution I've looked at, including, those of other vendors. You often specify the number of replicas. For us, it's often implied, but not necessarily. The solutions that I drew at the beginning basically all had 2 replicas or 2 copies. One interesting field you may not have thought of is the recover point objective. That's the time in seconds that the data may be stale, meaning it's the delay that's possible between the primary of the async copy and the secondary. And this is useful because, at least in our systems, certain systems allow you to set this. So you can set it to a lower number of seconds if your application's really important and you want it to consume tons and tons of bandwidth to keep the replicas up to date, or you can set it to a higher number for applications that are not so important and can stand to lose more of a window of time if they have to fail over. Another important one is the replication consistency group. When our arrays do replication, they have the ability to keep consistency across a number of volumes, just like volume snapshot consistency. And it's specified typically with a replication group, consistency group name of some sort that maps essentially to a volume group, just like volume group snapshots. And so that's a useful parameter that we might want to consider. Not all replication implementations have that ability. At least some of the ones I've looked at don't support that, but our array versions do support that. Statuses that might be useful, I think, whether it's normal, meaning all the copies are online and healthy, degraded, meaning some of the copies are not online, and rebuilding, meaning there are some copies that are behind and they're actively being rebuilt to be up to the current level of synchronization. If it's a synchronous replication, you're actively rebuilding the secondary copy. Rebuilding percentage is useful to give customers an idea of how long it will be until they're back fully protected, but it's optional, I think. Getting information about the various legs in order to correlate with the arrays is useful. Especially if you have the one PV solution, you need a way to figure out what that looks like within the arrays. And then the individual statuses of the legs are also interesting for troubleshooting. Is it connected or disconnected? So questions or thoughts about this?
Yeah. Wait, okay, I'm off mute. The user interface for some of those failover operations that you covered in the first few slides, do you have like a Kubernetes based UI, or is this like you go to some Dell tool outside of Kubernetes and trigger the various operations that you mentioned, like in the case of an actual failure?
So we do not have any sort of UI today. We announced one at the last Dell Technology World, so it's being worked on. But today what we have is essentially an interface like kube control. It's called repctl, and it allows you to make link state adjustments.
Okay. So the plan is some proprietary tool outside of Kubernetes that you can use, similar to kubectl, presumably, that would automate these operations.
Yeah, and I'll show you that maps to a CRD that we have, and I'll show you later on a definition, a high-level definition of that CRD. You could, Kubernetes itself, I mean, could have a similar sort of, I mean, it basically looks a lot like a volume group, right? But it has these extra things for managing the state of the replication. So it has actions and then statuses that show, am I failing over or am I failing back, and or the links up and those kinds of things.
Right. I mean, a lot of what you mentioned is like status reporting, which is all very valuable. But I think the most interesting bits are the control plane from from the perspective of this working group. Like we want to figure out, can we build a control plane which actually is portable, right? And so what I heard you say earlier is some of these cases are just transparent. Like Kubernetes doesn't even need to know, like a failure can just happen and like the right behavior occurs with no human intervention, that's the best case, right? Because those
Portworx is a great example of that, to be fair. So is our active metro. But
right.
but
But what I
uh,
was going to say is from the perspective of this working group, like those solutions, like we don't have to do anything. They're already available today. They're already possible to build today. Like so like those we can kind of put off to the side. Like that those are the easy cases.
right.
The hard cases are like if you must do something, can we define like the thing you must do in a way that actually works across, multiple vendors? Because that's where this all gets very sticky.
Yeah,
And
I
if
agree.
we can answer that question, then we've got a path forward.
Other than right now, all the parameters for defining something like our active metro, they all end up as being parameters in the storage group. And so if you wanted to define an application that said, I want this active replication in a vendor independent way, you don't have that today just because of the storage group,
Well,
really.
well, uh, suppose we left the setup part of it undefined or proprietary, and we focused on like the failure time behavior. So like after it's created, however, whatever proprietary parameters went into the volume creation, if CSI could say like, oh, by the way, I know that this volume has 2 replicas or something, and when and I can report on like which one is alive or whether they're both alive, and and if one of them is dead and I need to perform some switch operation, like CSI can help you with that. Can you imagine some failure time control plane operation where it's everything has already been set up and now the failure has occurred and we just need to do something
Yeah,
to
I can
get
imagine
back in the
that.
room?
I,
Like
I
could that part be done in common, do you think?
I don't know enough about the other vendor implementations to comment. I listened to your presentation on replication some time ago. It
Yeah.
was, I don't remember exactly how long, but I was there for your presentation, and I think our systems are relatively similar, our hardware systems, from what I know of them. So I think it might be possible, but I think we'd have to delve down into what are the particular operations and what do they mean and when can they be used and those kinds of things. And I'm
Yeah. I was still at NetApp when I made that presentation, and so it was about NetApp
yeah, yeah,
storage.
I know you've left NetApp, but
Yeah.
obviously I'm talking about the NetApp presentation.
Yeah,
So
yeah.
so
Yeah, so my memory of how that all works is that there's you can set up similar kinds of replication relationships, synchronous, asynchronous. I'm not aware that NetApp has any kind of bidirectional, but it wouldn't surprise me if they did. um, but then you want to be able to do things like a planned failover where I basically I want to test that this thing works.
yeah, we
Or
have those distinctions too. I haven't gotten
yeah.
into that level of detail where you can
Oh,
do
do you have more
planned
content to
or
present?
oh yeah.
Okay, but please finish your presentation. I won't keep peppering you with questions.
Oh, that's okay. This can be really interactive because I'm going to switch now into more of the implementation. So maybe this will prompt more questions. So just talking about our replication, we have 3 major components. We have a replication sidecar, and what you can think of the sidecar as something like the provisioner. So it sits with the controller side of the driver, and it handles operations on PVs, PVCs, replication groups, RG, the RG controller you see there. And it watches for changes on these objects and makes calls into the driver. The driver has some extensions, which are on maybe the next slide or a couple slides down, for doing things like creating a remote volume or adding a volume to a replication group, those kinds of things, or doing a link state operation like we've just been talking about. So there's this replication controller, and he's listening to PV states and PVC states and replication group states, and looking at the link status, and he's making calls into the driver. So the driver is not directly listening to this. This is truly a sidecar, like the provisioner. We have a replication group CRD, and this gets into some of the fields that I think would be interesting. So we control replication based on groups of volumes, and the groups of volumes are placed in this replication group CRD, or associated with the replication group CRD. There's an action string, and I didn't detail out all the possible actions, although I've talked about some of them. This action field here that does what you just suggested. I can set an action that says I want to do a failover, or I want to do a fail back, or I want to do I want to test failover, or I want to take a remote snapshot on the back side, the backup side. These are all possible actions, and they can be planned or unplanned. And so
So for the action, basically, if this is changed, the replication controller just watch this field and then trigger whatever action is specified there.
that's right.
Okay.
So when the action changes, that causes one or more calls, usually just one, into the driver to make that change. And that change affects the link state. And then there's a status that's generated that's returned. You can see in the status we have fields of the last action, the remote state, the replication link state, and the state. So those show the current state of the system as the action is processed and until it's completed.
Do
Let's see if
you
there's,
do you need to have two of this, one in each cluster, or just
I'm gonna get to that.
okay?
I'm gonna get to that. One thing you need to understand about our model, and there are some days that I like this aspect of it and some days that I don't, is the driver, let's say in cluster A, knows how to talk to both of the arrays. So when we set up the provisioning for the driver, he has the identities and the credentials of what will be both the active and the backup arrays, and the driver in cluster A can talk to both of those arrays directly. So if he needs to create remote volumes or do some link state operation, he can do that, and he can check it across the arrays, or she, if it's a female driver, I guess. I want to be gender neutral. My apologies. But the driver has that ability. There's another component that I'm going to get to in a second that handles the replication of the Kubernetes objects, basically the PVs and PVCs and this replication group CRD and storage classes across Kubernetes clusters. So that's another component. It works much like the global snapshot controller. In fact, it's pretty much modeled after that, and we call that the replication controller. So you essentially have the replication sidecar that's like the snapshot sidecar, and the replication controller that's much like the global snapshot controller. These are the methods that we added to our CSI driver to support replication. So there's a probe, there's get replication capabilities. Our arrays don't all have the same capabilities, so we have to ask, can we do this or that for a particular PV at times. There's create storage protection group. That's basically creating the internal storage representation of that replication consistency group. There's create remote volume, so that will create the volume on the backup array. There's create storage. Did I list storage protection group? I did. I listed that twice. Oh, no, that's delete. Sorry, getting cross-eyed. So we have delete of the storage protection group, delete local volume. That one doesn't make sense to me. I'll have to go look at that. I didn't think about that. There's execute action, and here at least is a longer list of some of the actions that give you an idea that we've been talking about. And then there's get protection group status, which is used to update the status in that CRD. So this is how the controller, the sidecar rather, interfaces with the driver. This happens, just by the way, on the same gRPC socket as regular CSI calls. There's not a separate socket interface for the driver. And then this is information about the replication controller, and it's managing persistent volumes, persistent volume claims, and the Dell CSI replication group custom resource across clusters. It does this by, it's directed by the CLI, which I don't really describe in this presentation, but the CLI allows you to register essentially remote clusters so that you know how to talk to them either with a token or with kube control or your kube config tokens, more secure way. But you can then issue CLI commands like copy this PVC from one cluster to another cluster. You can do failover operations with it. You can copy storage groups, and the way that or storage classes, and the way that our storage classes are often configured is in kind of a mirrored configuration. So if you think about array A has a certain set of parameters for replication, array B often has sort of the reflection of those parameters back to A. So they might be using the same replication group, but there's often a relationship between the parameters in a way that A knows about B's parameters and B knows about A's parameters, and we have our CLI supports taking the storage group and essentially converting it into the right, storage class, taking the storage class from one cluster for an array and turning it into the appropriate storage class on the other cluster that would match the backup array so that B could replicate to A or A could replicate to B. Hopefully I explained that well enough. Questions about that?
Sorry, so you only install this one in your local Kubernetes cluster. This replication controller, this only need to be installed in one of the clusters?
No, it's installed in each of the clusters, and it knows how to invoke operations in remote clusters. So A can invoke operations in B, and B can invoke operations in A, both using their local controller.
And then they communicate with each other so they know they don't like override each other?
No, they don't overwrite each other. The one that's essentially driving the provisioning is copying the data essentially to the other side, but it's usually CLI driven. So
Okay, so it's only going to be started in one. It's not going to be like simultaneously starting.
no, they don't
Clusters.
end up ping-ponging back and forth or anything like that.
Okay.
Yeah. This is the sequence of what volume creation looks like for at least for one class of volume. This is not the metro. This is more of a async kind of workflows. So you create a PV in the local Kubernetes cluster that goes to the CSI provisioner. That creates the volume just like normal, but there's also a listener in our replication sidecar, and our replication sidecar invokes an operation to create a remote volume that matches that PV. It's based on obviously things in the storage class, and we add annotations to the PV that sets up the relationship between this PV and say the remote volume. And so that gets both the PVs created. They still have to be put in a replication group, and the replicator, this is the sidecar, the replicator sidecar then creates the replication group and adds the volumes, and then generates a basically a request to generate the replication consistency group, which represents the protection group that was created on the array. And the replication group CRD gets sent to the AI or API, and the replication controller, this is the global thing, then knows to replicate the replication group CRD to the remote API. And the volume was also, or the PV was also replicated to the remote KS API. So, but of course, the PV that's replicated is the PV, the backup PV to the backup cluster, basically. It's not the same PV.
In your case, the PV will always be in a protection group, right? So you won't have any PV without a group, right?
Right. In our current implementation, we're always in some kind of protection group. It's called different things on different arrays, but it always exists. There are other storage providers that don't have that requirement or that facility. All right, let's see. I think that's near the end. Here's some example storage classes. You can see they get quite detailed. So you specify, the protection domain, you specify all kinds of things about the replication, like you've got the replication consistency group name here. You have the remote cluster that's going to use the replication. You can specify the usual retention and policies, and also the replication group retention policy. You specify the underlying storage class name. So this would be the name of the leg and the pool that it's from, the storage system. You've got the recover point objective here, which is 60 seconds. So these are some of the parameters that I talked about. The Metro replication is simpler because, again, a lot of this stuff is assumed in the Metro, but you do still have to specify a group and the remote symmetrics ID. That's essentially the array ID and the service levels. So all the proprietary information today gets passed in as parameters to the storage groups. I didn't show this, but I've mentioned it a couple of times. The PVs, I should show this. Maybe I'll get this for you, an example for later on, or just forward it via email if that's possible, or put it in the notes. We have, as I said, annotations that are added to the volumes that show the corresponding backup volume, for example, from the active and the replication group annotation, and I don't remember all what they are, but I could go look for those. But the idea is the annotations allow you, when looking at a PV, to figure out the associated PVC it should be mapped with, and the corresponding volume on a different cluster, if that makes sense. All right, I think I'm at the end of the slides. Questions?
Yeah, I think this is great. So, because we only have 8 minutes left, I do want to get you the status for CBT. I wonder, should we come back in the next meeting and then we can have more time to discuss this? Because I think it's going to take longer than just 10 minutes, right, to go through the questions.
It's fine. It's fine with me. Whatever works for you is okay.
Okay. What about others?
Yeah, I just wanted to thank Tom for going through this presentation and for making these slides. This was really great. A helpful view into how Dell does it.
Yeah. Thank you very much, Tom. Yeah. Can you join again in the next meeting, Tom? And then we can go through some questions.
Yeah, I will plan to.
Okay, that would be awesome. Thanks. So so now let's check the status for CBT and see where we are. We have a few minutes left, so so we have that CSS back, right? That PR. And are we getting close to get that merged?
Yeah, I think so I think the on the CSI spec, I think the last feedback was to include some of the clarifying language from based on James's feedback comment. I think like the action item was assigned to Carl.
Yeah, has Carl done that yet? Because James had asked for some. The language that I had proposed was confusing, and we all kind of agreed on that. And so he proposed some better language. I agreed to James's language, and so it just needed to be updated in the PR. So Carl needs to do that, but hasn't done it yet. Is that?
No, yeah, I don't think I haven't seen any new commits yet. So maybe
do you want to poke Carl?
Yeah, I'll ping him like after this call and just to get that in. Looks like we are very close to merging. I think this is the only last like pending action item.
So I can promise on my part that if that update goes in, I can approve it. But we got to strike while the iron is hot with James. So
yeah.
So the sooner we update it and get back in front of James again, the better, because he's the approval that it might take longer.
Is this already see that he did add some commits? I don't know. Does that mean he has already addressed it, or sure.
James on the CBT PR?
Carl has this 2 weeks ago. He did something. Let's see. I don't know if he. Well, maybe not. Okay, so maybe he just maybe just address those comments.
Yeah,
Zero. Okay.
there was some comments and some minor stuff, but
Okay, but
there
he
was like
didn't
one
change
last
the
language change that was going to be a couple lines of text
Okay.
updated.
All right. Yeah. Okay. So yeah, Ivan, yeah, please help ping him so we can get this one wrapped up.
Yep. Yeah, I'll ping him after this.
Okay.
So yeah, meanwhile, like there was some like addition to the cap side of things. John just asked us to, put in some like information for the scalability PRR section in terms of like, just like at least for like just some minor wordings and thoughts into it to see how we gonna manage differences between, say, you have a site, you have a CSI driver with a new sidecar, but then the CSI driver didn't implement it. How do we like propose to manage those situations? And what about like the versions of the volume snapshots, like CRD, like are we just gonna go with V1 support only? Just minor things like that. So I updated that.
That should be invisible, right?
Sorry, that should be what?
That should be invisible to, I mean, are we going to have a new controller that interacts with the Kubernetes API? Or will it all be, oh, I guess there will be. Okay, so we would have to, if we wanted to support V1 beta 1, we would have to explicitly do that, but we probably should not and just support V1.
Yeah, exactly. That's kind of
okay.
Yeah, that's what I added. For now, at least we're thinking only about V1. I guess again,
Yeah.
like those are just questions from John. He just asked us to, do our due diligence to show that at least we think about them. But yeah, otherwise,
if anyone's still on V1 beta 1, we could tell them they need to upgrade, because that's old.
yeah.
Oh,
yeah.
you mean the volume snapshot? Yeah, that's
Yeah.
Yeah.
Okay, that's like yeah, it's like several years.
Yeah, it's a couple years old.
Yeah.
Yep. So yeah, so as far as we know, like on the cap site, all the comments have been addressed. So yeah, hopefully we can move this along soon. Yep, that's all the updates we have.
Okay.
In terms of like Xing's your the GitHub repository owners.
Oh yeah. What about that?
Yeah. So yeah, like at least on our side, I'll need like I thought I thought I already have an answer, but now like something happened earlier this week, so give me a few more days and then I'll get back to you with a final confirmation.
Oh, okay.
So I haven't heard from Prasad or Carl in terms of yeah, in regards to that. But yeah, so on my side, like just give me a few more days to finalize some details.
Okay, basically you just want to from your company, right? You need to get some approval.
Yeah. I actually had an answer last Friday, and then something changed earlier this week, so now I have to
Okay.
just give me a few more days.
Okay.
Thanks.
All right, thank you. Okay, let's see there. Okay, so those are all the those are all the questions. Okay. All right. I think then that's it then. We just well, then I'll add a note here that we'll get back. Yes.
Mark, did you hear from either Prasad or Carl in regards to the new GitHub repository ownership matter?
We discussed this a bit, and Dave Smith-Lucid is definitely going to reach out to Xing a little bit more for discussion because we're still not sure what's the best way to go forward. So we want to get some more counsel. I don't know if it's appropriate to discuss here, though.
Okay, yeah, we can talk about that offline.
Thank you.
All right. There's some. Ben, are you trying to talk or? It's just background.
Sorry, it's
Okay.
probably background noise. I gotta run on my next meeting.
Oh, okay.
it's gonna
Also,
drop off.
yeah, I think it's on the top of the hour, so I also need to go. All right. Okay. Thank you, everyone. Let's meet again in 2 weeks.
Thanks, everybody.
All right. Thanks. Bye.